All right, we want to find the derivative of y equals 3x minus 1 over x squared plus 3 to the second power. Right, so we are going to have to use the chain rule, and the quotient rule is going to be incorporated into this. Because when we take the derivative, it's going to be twice 3x minus 1 over x squared plus 3 to the first power times the derivative of 3x minus 1 over x squared plus 3. So this is another case where it's, if you are not neat and can't follow your own work, you're going to get messed up. We're using the chain rule, and now to find the derivative of the inner function, we have to use the quotient rule. All right, so quotient rule is denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. Right. It's really not as bad as it might look like. So we have 2 times 3x minus 1 over x squared plus 3. Now we can simplify our numerator sum. We have 3x squared plus 9 minus 6x squared plus 2x. Pay attention to signs. We have to distribute that negative. All right? So we've got our first part of this problem. And 3x squared minus 6x squared is negative 3x squared. Plus 2x plus 9. Now really here, the only thing that we can do to simplify this any further, notice I have,
Wait, should it be squared?
yes it should, thank you, and I may not be able to erase it at this point.
Oh, well.
That should be squared. All right, now notice I have x squared plus 3 times x squared plus 3 squared, so my denominator becomes x squared plus 3 cubed. And the rest of it, there's not much we can do with, so we can just, pardon? Because we have a first degree and a second degree, so you just add those exponents, same base.
Oh, I see. Okay, I got
Okay.
it. Yeah.
So this is really just an algebra thing at this point, and you don't have to multiply it any further than that. But I would like you to combine those that have the same base. Okay. So you will have a problem or two like this on your homework. I took it, originally it would have been on today, what was due today, but I took it off since we didn't have time to talk about it. Now, the chain rule also applies to our trig functions. So let's look at some examples using trig functions to be sure that we remember that the derivative of the sine of u, if u is a differentiable function of x, what's the derivative of the sine? So this is going to be the cosine of u times the derivative of u times u prime. Because we're using the chain rule. If u is a differentiable function of x, then it's the derivative of the outer function, the derivative of the sine, which is cosine, times the derivative of whatever this is.
just saying, it's just cosine u.
U is a differentiable function of x. U could be x squared.
Does that mean the derivative?
So if we wanted to find the derivative of the sine of x squared, well, that would be the cosine of x squared times the derivative of x squared, which is 2x. And usually you'll just put that in the front. All right, so what's the derivative of the cosine? Negative sine. So if we have u's a differentiable function of x, this is going to be negative sine of u times the derivative of u. What was the derivative of the tangent?
Secant squared.
Okay, that's secant squared u times the derivative of u. Let me see if I can move. No, I can't move that out by itself. What's the derivative of the cosecant?
Negative cosecant squared cotangent.
Negative cosecant u, cotangent u times the derivative of u. No. Not the chain rule. But if I can't remember if I put trig functions on there, but we're reviewing the trig functions, so that should be helpful if they are. What's the derivative of the secant?
Secant u.
In this case, secant u, tangent u, times u prime. Always before we just used x. What's the derivative of x? 1. So we were doing the chain rule, but when the derivative of the inner function is just 1, it's not an issue. And then finally, the derivative of the cotangent. Negative cosecant squared u times u prime. Okay, so let's just look at some examples. Let's say that we have y equals the sine of 2x. What's y prime? Cosine. This stays the same. Cosine of 2x. What's the derivative of 2x? 2. We had y equals the cosine of x minus 1. Well, what's y prime? Negative sine. This stays the same. Now, what's the derivative of x minus 1? Just 1, so that's the derivative. We don't have to do anything else to that. Whatever this happens to be is going to be in your derivative. If we had y equals the tangent of 3x, what's y prime? Secant squared 3x times 3. So it's not difficult if you know your trig functions, right, Christian?
Right.
All right. One thing we want to be sure that we pay attention to is parentheses, because that can change your answer where your parentheses are placed. For instance, if we have y equals the cosine of 3x squared, notice that would be the same as the cosine of 3x squared. This is probably a preferable way to put it. So, with the parentheses. So that you realize that it's not x squared times the cosine of 3. All right? So what is the derivative of the cosine? So negative sign of 3x squared, now what's the derivative of 3x squared? 6x.
Oh, 6 there.
Okay. Normally, we'll put that in the front
Normal.
so that there's no confusion there. What about if I had this problem? Y equals the cosine of 3 times x squared. Do we have to use a product rule?
No. No.
Why not?
You can distribute that x to the second.
Well, what is cosine 3? Do we have an x here?
No.
This is a constant.
So you can just zero.
So, no, it's just a constant, so it is going to be 2x times the cosine of 3. Because the cosine of 3 is just a constant.
But you didn't include constants.
Pardon?
But you didn't include
So you only needed to do a derivative of the x to the
Yes,
second.
you include constants. If you're taking the derivative of a constant, that's 0, but we're taking the derivative of the cosine of 3 times x squared. If I have 4x, what's the derivative of that?
4.
Same thing. If we had 4x squared, what's the derivative? 8x. So we're doing the same thing with 2x, or cosine 3 times x squared. I mean, if this had been a 4, you wouldn't have had a problem with it. But this is just a constant, because there's no variable right there. So parentheses are important if we have, I think we saw this last year, but just so that you realize that y equals the cosine squared x is the same as the cosine of x squared. So if we want to take the derivative, we have to use the chain rule. So the derivative of the outside is twice the cosine of x to the first power times the derivative of the inside, which is negative sine x. Same thing if you had y equals the square root of the cosine of x. That's the same as cosine x to the 1/2. And here you would have to use the chain rule. Now, there may be times when you've got multiple applications of the chain rule. All right. First thing I want to do here before I take the derivative is just rewrite it like this. Now I can see what's the inner function and what's the outer function, right? What the inner function is the sine of 4t. So if we take the derivative, it's going to be 3 times the sine of 4t squared. What's the derivative of the sine of 4t? Cosine 4t. And what's the derivative of 4t? So this becomes 12. And if you want to write it this way, you can.
Wait, where'd you use the 4?
Derivative of 4t.
That's because it's cubed. Why you take the derivative of 4t?
No, it's because it's cubed is why we have to take the derivative of the sine of 4t. And then we still have to, this is like another u. We still have to take that derivative again.
Okay.
It's not the constant.
Yeah, because it's not a constant. Page 134, 33, 47, 50, 55, 62, 65, 67.
71.
Did I write 77 twice? 81, 89, and 90. All right.